Hello everyone, in this video we're going to review Unit 5 of AB, Calculus AB and BC, Analytical Applications of Differentiation. Question 1. The graph of the choice differentiable function f is shown in the figure. Which of the following correctly orders f of 2, f prime of 2 and f double prime of 2? Alright, so this is the function f. Now, function f has f of 2 equals 0, right? Now, at s equals 2, we draw the tangent line. We see that the tangent line is going down, which means the slope of the tangent line is negative, right? Remember Christmas tree trick. This one, slope positive, slope negative, slope is 0, and slope is undefined, right? So, f prime of 2 less than 0, right? Right at s equals 2, the function is concave up, right? So it tells us that f double prime of 2 greater than 0, right? So the answer must be C, right? Now let's move on to question 2. A rectangle is bounded by the x and y axis and the graph of y equals 6 minus x over 2 as in the figure below. What length and width should the rectangle have so that its area is a maximum? Alright, now this guy actually the optimization problem. In order to solve this problem, you need two equations. The first one is called secondary equation. The second one is called primary equation. Now secondary equation is what given. Alright, so given is right here, right? It's going to be y equals 6 minus x over 2. Primary equation is what the question asks you to find, right? So this one is right here. We tell you the primary equation, right? What length and width should the rectangle have so that its area is maximum? So the area is, I'm going to call the length of the rectangle is s, and the width right here is y, right? So a equals s times y, right? Now we're going to substitute 6 minus s over 2 for y into the primary equation. So we're going to have s times 6 minus s over 2, right? And we need to maximize this one, right? So we're going to distribute this one. So a equals 6s minus s squared over 2, right? Now we're going to simplify this one. So I'm going to write this one as negative 1 over 2 s squared plus 3s, right? And then I'm going to take the derivative of this one, right? So it could be negative s plus 3, right? Now I'm going to let the derivative equal 0 to find the critical number, right? So a prime equals 0 is the same thing as negative s plus 3 equal to 0, and then s equals 3. Now let's find the second derivative, right? So it could be f the program equals negative 1 less than 0, right? So from this information, we can conclude that a is maximum when s equals 3, right? So we substitute 3 for s into the function right here to solve for y, right? So we have y equals 6 minus 3 divided by 2. It's going to be 3.5, right? So finally we have s equals 3, y equals 3.5. Now let's move on to question 3. Let f(s) be a strictly increasing function, such that f of s less than 0 for all values of s. Let g be a strictly decreasing function, such that g of s greater than 0 for all values of s. Now, given h of s equals fs times g of s, which statement is true? A. H of s greater than 0 and strictly increasing. B. H of s greater than 0 and strictly decreasing. C. H of s less than 0 and strictly increasing. D. H of s less than 0 and strictly decreasing. Alright, so we need to take the first derivative of the function h of s, right? So we have the product rule, right? So it could be f prime of s times g of s plus g prime of s times f of s, right? Now we're going to use the information right here. Since the function f of s is strictly increasing, it tells us that f prime of s greater than 0, right? The function g of s is strictly decreasing. It tells us that g prime of s less than 0, right? So we have f prime of s is positive, right? G of s is positive, right? And g prime of s is negative. F of s is negative, right? So positive times positive is positive, plus negative times negative is going to be positive. The final answer is a positive number, right? So we can conclude that h prime of s is greater than 0, right? It tells us that the function h of s is increasing, right? If we look at this one right here, h of s equals f of s times g of s, but f of s is less than 0 right here, right? And g of s is greater than 0 right here, right? So this one should be negative, right? Which is less than 0, right? So h of s less than 0, we need to eliminate a and b, right? And then h of s should be increasing, right? Less than 0 and increasing, the answer must be C. Now let's move on to question 4. A right circular cylinder can is to be designed to hold 20 cubic inches of a liquid. The cost for the material for the top and the bottom of the can is 0.02 per square inch. The cost of the material of the side of the can is 0.01 per square inch. Let R represent the radius and H the height of the cylinder. Alright, so we just get the figure right here. The lateral area of a cylinder is A equal 2 pi R. The area of the circle is pi R squared. The volume of the cylinder is pi R squared times H, which of the following represent the correct primary and secondary equation in order to maximize the total cost of manufacturing the can. Alright, so remember the secondary equation is what's given. Alright, so given right here, 22 cubic inches. Right? Now, this guy is the same thing that V equals pi R squared times H equals 22. Now, primary equation is what we need to find, right? The primary equation is the cos, right? The cos equals the lateral surface area, right? So it could be 2 pi R times H plus The area of the base is pi r squared, right? Since we have two bases, so we need to multiply by 2. Now, the cost for the material of the side of the can is 0.01 per square inch, right? So we need to multiply this guy by 0.01, right? And the cost for the material for the top and the bottom of the can is 0.02, right? So we need to multiply this guy by 0.02, right? And this one is the primary equation, right? So we look at the answer choice. It should be C, right? Now let's move on to question 5. The graph of the function y equals h of s is shown above. Which of the following could be the graph of the function h prime of s? Alright, so we look at this one right here. We see the maximum right here. Right, this one is the relative maximum. This one is the relative minimum. We will check down to the axis, and this guy actually the zero of the function h prime of s, right? So we have 0 right here. Now we look at the answer choice right here. We see that 1, 2, 0, 1, 2, 0, and 1, 2, 0. This guy only have 1 0 right here, so this one is wrong, right? Now next one, we draw the tangent line right here. So we see that the tangent line goes in this way, which means the slope is positive, right? Remember the Christmas tree trick: positive, negative, 0, undefined, right? So it tells us that the function h prime of s greater than 0, right? And then if h prime of s greater than 0, the function h prime of s should be above the axis, right? So this guy is above, right? This guy is below, right? So we need to eliminate this one, right? Similarly, the slope of the tangent line of this one is positive, right? And then this one should be above the axis, so it could be above the axis right here, right? This one is still above. Now observe that this one is the cubic function, right? Derivative of the cubic function should be the quadratic function, right? So the first derivative graph of this function should be quadratic. The answer must be D. Now let's move on to question 6. The figure below shows the graph f prime, the derivative of the function f for the interval -7 to 7. The graph of f prime has horizontal tangent line as equal -3, right? It's right here. And s equal 2 is going to be right here. S equal 5 is going to be right here, right? And the vertical tangent line s equal 3. Question 8. For all value of s, for s from -7 to 7, at which f attains a relative minimum. Alright, so first we need to find the 0 of the function f prime of s first, right? So we have 1 0 right here, the second 0 right here, right? And the third 0 right here, right? Now we look at this one right here. The function f prime is above the axis right here, right? So it could be positive, and then negative, right? From here to here is positive, right? And from here to here is going to be negative. From here to here is positive, right? And this one is positive. This one is positive, right? So we look at the side change, right? This is positive, this is negative. This is negative, and this one is positive, right? We know that the function f attains a relative minimum when f prime of s changes sign from negative to positive, right? It's going to be like this. So this one is the minimum, right? If it changes sign from positive to negative like this one is the maximum, right? So we see that the function f attains a relative minimum as equal -1, right? Because f prime of -1 equals 0, and f prime of s changes sign from negative to positive, at s equals -1, right? Now let's move on to question B. Find all value of s for s from -7 to 7 at which f attains a relative maximum, right? So similar to question A, the relative maximum is at s equals -5, right? So we do exactly the same thing. The graph of Ls has a relative maximum at s equals -5 because f prime of -5 equals 0 and f prime of s changes sign from positive to negative at s equals -5, right? Now let's move on to question C. Find all intervals for which f double prime of s less than 0. Now if f double prime of s less than 0, it tells us that the function f prime of s is decreasing, right? Now we just look at the graph to find the interval where f prime of s is decreasing. Now f prime of s is decreasing on this interval -7 to -3, right? And from 2 to 3, right? And from 3 to 5, right? Now we're not gonna count 3 because the graph of f prime has a vertical tangent line here, right? Now let's move on to question D. Find all values of s for s from -7 to 7, where the function fs has a point of inflection. Now, point of inflection means f double prime of s equals to 0, right? So we need to find the value of s where f double prime of s equal to 0, right? So we go back over here. F double prime equal to 0 is right here. Horizontal tangent line right here. -3, 2, right? And 5 right here. Now you need to be careful. The point of inflection occurs when f double prime changes sign. So we draw the tangent line right here. We see that the slope of the tangent line is negative. And draw the tangent line right here. The slope of the tangent line is positive, right? So which means the sign of f double prime changes from negative to positive. Similarly, this one right here, positive. This one right here is negative, right? Now for this one right here, it's going to be negative, and this one right here is going to be positive, right? So the sign of f double prime changes at s equals -3, 2, and 5, right? Now we need to conclude that the graph of LS has a point of inflection at s equals -3, s equals 2, and s equals 5 because f double prime of -3, f double prime of 2, and f double prime of 5 equal to 0, right? And f double prime of s changes sign at each of those values, right? Now let's move on to question 7. The graph of the second derivative of a function fs is shown below, right? So this one is f double prime of s. Which of the following is true? The graph of fs has a point of inflection as s equals -1. So we need to check f double prime of -1 equals to 0 or not. And f double prime of s changes sign at s equals -1, right? So we check it. Yes, right here. -1 is the 0 of this function, right? And f double prime changes sign from positive to negative, right? This one is positive because it's above the axis. This one is negative because it's below the axis, right? So one is correct. Now 2. The graph of LS is concave down on the interval -1 to 3. So negative 1, 2, 3 is going to be from here to here. Right? Within this interval, f the program of s is less than 0, right? Because it's below the axis, right? So if f the program of s less than 0, the function f of s is concave down, right? So this one true. Now, number 3, the graph of f prime of s is increasing at s equal 2. S equal 2, we have f the program of 2 is less than 0, right? Right here. So it tells us that the function f prime of s is decreasing at s equal 2. So this one is wrong, right? So only 1 and 2 correct. It's going to be C. Now let's move on to question 8. Given the graph of the derivative f prime of s, which of the following would correctly depict possible graph of f of s, right? So we need to reconstruct the function f of s from the function f prime of s, right? So we look at this one right here, we see that the function f prime right here has the vertical asymptote as s equals 3. So we observe that this one has the vertical asymptote as equals 3. This one has the vertical asymptote as equals 3. This one has the vertical asymptote as equals 3, right? This one doesn't have, so the answer C should be wrong, right? Now observe that the function f prime of s is less than 0 because it's below that axis from the interval negative infinity to 3, right? So it tells us that the function f of s must be decreasing on this interval, right? So we look at this one right here, we see that the function f of s is increasing, right? So this one is wrong. Now this one is increasing, so this one is wrong. Only B correct, right? Now let's move on to question 9. Use the graph of f on the right to estimate the value of c that justify the mean value theorem for the interval 0 to 7. Alright, so 0 which means A, 7 which means B. The mean value theorem is f prime of c equals f of b minus f of a over b minus a. This one is the slope of the secant line, and this one is the slope of the tangent line. So if these two slopes are equals, two lines must be parallel, right? Now a equals 0 is, and then f of a should be right here. B equals 7, f of b should be right here. We connect these 2 points. And the slope of the secant line is f of b minus f of a over b minus a, right? This one is a, this one is b. Now we look at the answer choice right here: 3.7, 4.3, 5.5, and 7. So we're gonna sketch the tangent line at s equals 3.7, 4.3, 5.5, and 7, right? So it could be something like this, and 4.3 is could be something like this, and the last one is right here. Now among these 4 values right here, only these values give 2 lines parallels, right? So the value right here should be 3.7, right? So the answer must be A. Now question 10. Engineers are designing a box-shaped aquarium with a square bottom and an open top. The aquarium must hold 500 cubic feet of water. Which of the following represent the correct primary and the secondary equations? In order to find the dimension they should use to create an aquarium with the least amount of glass. Alright, remember the primary equation is what you need to find, right? The secondary equation is what's given, right? So given right here, 500 cubic feet of water, right? So cubic feet tells us that this one is the volume, right? Now the volume of the rectangular prism right here, right? It's gonna be length times width times height, right? So length times width times height is gonna be s squared times y, and this guy actually 500, right? And this one is the secondary equation, right? So we check the answer choice right here. This one could be right, right? This one wrong, right? Because 500 equal this one, so this one is wrong. This one could be right, right? This one is wrong because this is set as y, so wrong. Only C and B. Now we check the primary equation, right? So we need to find the surface area, right? The surface area is the lateral area plus the area of the base, right? Now, because this one is open top, so we don't need to count this one, right? We just count the bottom. The bottom should be s squared, right? The lateral surface area is the perimeter of the base times the height, right? So the base is the square, right? So it could be 4 times s and then times the height, which means y. So this one is the surface area and this one is the primary equation, right? So the answer must be B. Now question 11. Identify the open interval on which the function fs is s squared minus s minus 12 is increasing, right? So we just check the derivative of this one. It's gonna be 2s minus 1, right? And then we're gonna let f prime of s equal to 0. Is the same thing as 2s minus 1 equal to 0, right? And s equals 1/2, right? Now we're gonna get the side charge. We're gonna put negative infinity right here, positive infinity right here, 1/2 right here, right? We're gonna pick the number 1. Substitute number 1 into f prime of s right here, right? So it's gonna be 2 times 1 equals 2 minus 1 is gonna be 1. So this guy is positive. If this guy is positive, this guy must be negative, right? Now we need increasing, right? Which means this guy right here, right? F prime of s greater than 0, right? From 1/2 to infinity, right? So the answer must be D. Now question 12. Suppose Ls is differentiable everywhere and f of -2 equals -5. F prime of s less than or equal to 5 for all value of s. Use the mean value theorem. What is the largest possible value of f of 8? Now we know that the mean value theorem is given by the formula f prime of c equals f of b minus f of a over b minus a, right? So f of a is right here, f of b is right here. So we substitute. We have f of 8 minus f of -2 over 8 minus -2, right? And this one is f prime of c, right? But f prime of c is less than or equal to 5 right here, right? So we need this one less than or equal to 5, right? So we substitute value f of 8, we don't know, right? So we just rewrite f of 8 minus f of -2 equals -5. So it turns out to be plus 5 over 8 plus 2 is going to be 10 less than or equal to 5, right? Multiply both sides by 10. We have f of 8 less than or equal to 50 minus 5 is going to be 45. So f of 8 is at most 45, which means the largest number is 45. The answer must be B. Now let's move on to question 13. For all value of s in the closed interval 2 and 5, right? The function f is a positive first derivative and a negative second derivative. Alright, so which means f prime of s is greater than 0, f double prime of s is less than 0. Which of the following could be a table of the function f? Alright, so we see that if the function f prime of s greater than 0, which means the function f of s is increasing on the closed interval 2 and 5, right? So we look at the f of s right here, right? If s1 greater than s2, then f of s1 must be greater than f of s2 by definition of increasing function, right? So we see that s is increasing right here. The y value is increasing right here. So a right here could be right. B right here could be right? Because s increasing and y is increasing, right? Now C, f of s decreasing, right? So this one is wrong. D, f of s decreasing, so this one is wrong, right? Now f double prime of s less than 0, it tells us that f prime of s is decreasing. Now we need to find the average rate of change for this one right here, right? Now 9 minus 7 divided by 3 minus 2 is going to be 2, right? Now 12 minus 9 divided by 4 minus 3 is going to be 3, right? 16 minus 12 divided by 5 minus 4 is going to be 4, right? This one, 11 minus 7 divided by 3 minus 2 is going to be 4. 14 minus 11 divided by 4 minus 3 is going to be 3. 16 minus 14 divided by 5 minus 4 is going to be 2. And observe that f prime of s right here is increasing, right? And f prime of s right here is decreasing, right? So we need f prime of s is decreasing, right? So the answer must be B. Now question 14. On the closed interval 0 to 2 pi, the absolute minimum of f of s is e to the sine s occurs at one of these values, right? So we need to take the derivative, right? So f prime of s equals, we're going to use the formula e to the u prime. It's going to be u prime times e to the u, right? So u in this situation is sine s, right? So sine s prime is going to be cosine s times e to the sine s, right? Let f prime of s equal to 0 is the same thing as cosine s times e to the sine s equal to 0. So this one is the 0 product, right? Cosine s equal to 0 and e to the sine s equal to 0. Cosine s equal to 0. Within this interval, s must be equals pi over 2 and 3 pi over 2. Now this one right here has no solution, right? Because e to the sine s right here always greater than 0, right? We're going to use the candidate test because this one is the closed interval, right? Now substitute 0 for s into the original function right here. So we have e to the sine of 0. It's going to be e to the 0 equals 1. E to the sine of pi over 2. It's going to be e to the first and it's going to be e. This is e to the sine of 3 pi over 2, right? So it could be e to the negative 1 and it's going to be 1 over e. And the last one, e to the sine of 2 pi, right? So it could be e to the 0 and it's going to be 1, right? Now we need the absolute minimum, right? So absolute minimum is 1 over e right here, right? So s equals 3 pi over 2. The answer must be C. Now let's move on to question 15. Let g be the function given by g of s equals s squared times e to the ks, where k is a constant. For what value of k does the function g has critical point as equal 2 over 3? Alright, so we need to find the first derivative, right? So g prime of s equals, we need to use the product rule, right? U times v prime equals u prime v plus v prime u, right? So it's going to be 2s times e to the ks plus e to the ks. So we have e to the u. It's going to be u prime times e to the u, right? So this one turns out to be k times e to the ks times s squared, right? Now since the function g has a critical point as equal 2 over 3, right? So which means g prime of 2 over 3 right here must be equal to 0, right? So we have 2 times 2 over 3 times e to the 2 over 3k plus k times e to the 2 over 3k times 2 over 3 square equal to 0, right? And then it's going to be 4 over 3 e to the 2 over 3k plus k times e to the 2 over 3k, right? And this one turned out to be 4 over 9, so I put 4 over 9 right here equal to 0. Now I'm going to factor 4 times e to the 2 over 3k out. So it could be 1/3 plus 19k equal to 0, right? This one is the 0 product, so each of them must be equal to 0. So we have 4 e to the 2 over 3k equal to 0, and 1 over 3 plus 1 over 9k equal to 0. The top right here has no solution because this one always greater than 0, right? Now the bottom, 1 over 9, k equals negative 1 over 3, k equals negative 1 over 3, divide by 1 over 9, which means multiply by 9 over 1, right? So it could be negative 3, right? So the answer must be A. Now let's move on to question 16. The maximum value of the function f(s) on the closed interval 0 for is. Again, we need to find the critical values, and then we're going to use the candidate test, right? So we have f prime of s is 6s squared minus 30s plus 36, right? And then we let 6s squared minus 30s plus 30 equal to 0. Oh, this one is 36. Now divide both sides by 6, so we have s squared minus 5s plus 6 equal to 0. Now we're going to factor this one using s method. Right, this one 6, this one is negative 5, 5 two number multiply equal 6 add up to negative 5, which is negative 2 and negative 3. So s minus 2 times s minus 3 equal to 0. So s equal 2 and s equal 3. So we have 0 right here. Next one is 2, 3, and 4, right? This one and these two guys right here. Now f of 0 is 0, right? F of 2, substitute over here. You have 2 times 2 cubed minus 15 times 2 square plus 36 times 2. The answer is 28. Now this one, 2 times 3 cubed minus 15 times 3 square plus 36 times 3. The answer is 27. And the last one, the answer must be 32. Alright, now we need the maximum, right? So maximum is 32 right here. The answer must be C. Now let's move on to question 17. Consider the function f divided by fs equal s squared over s squared plus 3. Question A. Find any critical numbers if possible. Alright, So in order to find the critical numbers, we need to find the first derivative, right? So we have f prime of s equals. Now we're going to use the quotient rule, right? We have u over v prime. It's going to be u prime v minus v prime u over v squared, right? So it's going to be 2s times s squared plus 3 minus 2s times s squared over s squared plus 3, right? Now distribute this one and simplify. The answer must be 6s over s squared plus 3, right? So we need to have 6s over s squared plus 3 equal to 0. It's the same thing as 6s equal to 0, right? And then s equal to 0, right? Now in this situation, we don't need the denominator equal to 0 because denominator always different from 0, right? So we don't need to find the value of s squared. F prime of s is undefined because denominator right here always positive, right? So the critical number is s equal to 0, right? Alright, so we're gonna sketch the side chart. Negative, infinity, positive, infinity, 0 right here. Alright, so we just pick a values 1 right here. We substitute 1 for s into the first derivative right here. Right? It's going to be 6 over 4. It's going to be positive, right? So this interval is positive. If this one positive, this one must be negative. We need to identify the intervals where the function is increasing and decreasing, right? And then we need to say the location of any extrema, right? So this one is decreasing, this one is increasing, and this one is the minimum, right? Now we need to conclude that the function fs is decreasing on the interval negative infinity to 0, right? Because f prime of s is less than 0, right? And the function fs is increasing on the interval 0 to infinity because f prime of s is positive on this interval, right? Now there is a relative minimum at s equals 0 because f prime of s changes sign from negative to positive at s equals 0, right? Now let's move on to question C. Solve f the problem of s equal to 0. So previously we have f prime of s equals 6s over s squared plus 3 altogether square. Oh. So I'm gonna go back over here. I need to fix this one. This one must be square, right? Sorry, I missed this one. Right? Alright, now we need to take the second derivative of this one. So we have f the program of s equals. Again, we're going to use the quotient rule, right? So u prime is going to be 6 times s squared plus 3 altogether square minus derivative of this one. We're going to use the power rule, right? It's going to be bring 2 to the front, right? And then s squared plus 3 power of 1, right? And then times derivative of the inner function right here, it could be 2s, right? So I'm going to put it over here. It should be 4s times s squared plus 3, right? Over s squared plus 3 altogether square, and then square is going to be power 4, right? Now I'm going to factor s squared plus 3 out. So it's going to be 6s squared plus 18, right? And then if I factor this one out, I have negative 24s squared left, right? Over s squared plus 3 to the 4, right? Now this guy cancel out. So the top is negative 18s squared plus 18 over s squared plus 3 cubed, right? Now we just let this one equal to 0 is the same thing as the numerator equal to 0, right? So it's going to be negative 18 s squared plus 18 equal to 0, and then s squared equals 1, right? And then s equals plus and minus 1, right? Now let's move on to question D. Construct a chart on a number line and use the test for concavity to determine the intervals of concavity and state any points of inflection, right? So we're gonna use the number line. Negative infinity, positive infinity, negative 1 and 1, right? This one is the second derivative. Keep that in mind after program. Alright, now you're gonna test a number. So I'm gonna pick a number 0 right here, right? I substitute 0 for s into the second derivative to test the sign, right? Substitute this one over here, right? So it's gonna be positive, right? So this one positive. If this one positive, this one must be negative. This one must be negative. So that f the program is negative on these two intervals, right? So the function f must be concave downward, right? And this one is concave upward, right? Because f the program is greater than 0 on this interval, right? Now there are points of inflection at s were negative 1 and 1, because f the program of negative 1 and f the program of 1 is 0, and f the program of s changes sign from negative to positive and positive to negative, right? Let's move on to the last question. Construct the graph of f on the coordinate plane below. Alright, so we're gonna go back to the function f of s. It could be s squared over s squared plus 3, right? So we have the function f of s equals s squared over s squared plus 3. Now observe that the degree on the numerator and degree on the denominator are the same. So the function has the horizontal asymptote y equals 1, right? Coefficient right here is 1, coefficient right here 1, so 1 divided by 1. Or you can find limit of the function f of s when s approaches positive and negative infinity equals 1, right? So the horizontal asymptote is right here. Now the function has the critical number s equals 0 right here, right? And at s equals 0, the function obtains the minimum value, right? And you know that the function has two points of inflection at s squared plus and minus 1, right? So it could be something like this. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in